All right, we are going to continue our talk about section 5.4 in this video. We are going to move into the idea of solving logarithmic equations. Now, unlike exponential equations where we've already kind of talked about both different ways to solve them, we haven't talked about any ways to solve logarithmic equations yet. So in this video, I'm going to talk about the easier way that shows up when solving logarithmic equations. And then in the next video, I'll wrap up this idea by showing you some that may be a little bit more difficult for some students. And so we'll talk about those at that time. So in this video, when it comes to solving logarithms or solving a logarithmic equation, one of the things that we're going to look at is first what's called where's my highlighter? The logarithm property of equality. And so what this says is that if you have a logarithmic equation, and it can be written in the following form, where you have a logarithm on one side and you have a logarithm on the other side. Well, what you should notice about both of these logarithms is that they both have the exact same base. So if you're able to simplify an equation where there's a logarithm on one side and a logarithm on the other, and they have the exact same base, all you have to do is take the information that is inside the logarithm. So in this case, that would be u and v, and you would set them equal to each other and solve that equation instead. All right. So there is a nice simple way of solving this. So, but this, once again, this only works if there's a logarithm on both sides. When there's only a logarithm on one side of the equation, that's what the next video will be about and how to solve those. So just a couple of notes down here that I put. We won't always do all of these steps every single time, but I did want to kind of make sure you're aware of some of the steps we'll have to do in this video and even the next one. So first of all, one of the problems with solving logarithmic equations is that not every answer you find may work. So one of the things that we'll have to do, and you'll see it here on step 1 and even on step 5, the domain of a logarithm is restrictive. Because if you remember from when we covered logarithms in section 5.2, we talked about that you can only plug numbers into logarithms that are positive. So there may be some answers that we get that would give you a negative logarithm value, and that's not something that we can have. So I'll show you how to check those when we get to our first problem. Other than that, just a couple other advice tips I have for you is if you do have multiple logarithms on one side, make sure you go back, and if you have to, we will use any properties of logarithms that we've learned in order to combine to a single logarithm on both sides, because we don't want two logarithms on the left and one logarithm on the right. We want to get these down to one logarithm on the left and one logarithm on the right. Because once you do that, what the logarithm property of equality says, you will eliminate your logarithms and then you will solve directly for the given variable. All right. So what we've got here is we're going to look at a few examples of how to work problems like this. So use the equality property of logarithms to solve each logarithmic equation. Reject any values that are not in the domain of the original expression. And once again, I'll show you how to do that when we get to the end. I always check that part at the very last second. So as you can see on number 1, we've got log base 3 of 2x plus 1 is equal to log base 3 of 11. So what our rule says is that if you can look at both sides of the equation and there is a single logarithm of the same base, which we do, we have a log base 3 and a log base 3, what we are allowed to do is essentially eliminate those logs, and we are only going to focus on the information that is inside the logarithm. So I would bring down the 2x plus 1, and I would set this equal to 11. Logarithms are not needed anymore because they're already condensed. And then you can solve this equation pretty quickly. We can subtract 1 from both sides. That would give us 2x equals 10. And if you divide both sides by 2, you will get x equals 5. Now, what you'll notice is that I'm not going to box that in just yet. when you're solving logarithmic equations, and we'll cover this in the next video as well, before you box in any of your answers or type them in your assignments, you need to make sure that they don't cause a domain error. And so what you will do is you will look back up at the original problem. And there's a reason why I used a green box around each one. All right. In those original logarithms, if you can plug your value into either one and they give you a negative answer, that means you cannot use that answer you found. So if I were to plug 5 into that first logarithm, 2 times 5 is 10, and 10 plus 1 is 11. That is fine. 11 is a good answer. On the second logarithm, there's nowhere to even plug an x in, so you don't have any issues with that one. So in this case, x equals 5 is a solution to this problem. But I will warn you, the one time that you do not check your solution will be when you have an issue show up. And we'll see that show up here in just a minute in one of these next few problems. So speaking of that, let's look at number 2 and see if it has any issues. If you have 2 times the natural log of x plus 5 is equal to the natural log of 12 plus the natural log of 3. So on this one, you've got more than just a single logarithm on each side. On the left-hand side, you've got a random 2 in the front, so we have to deal with that. And on the right, you've got 2 logarithms added together. Well, if you remember, we learned properties of logarithms in section 5.3 of how to simplify these. We talked about that if you have a number in the front, you can bring that inside the logarithm and make it the exponent. So this would be the natural log of x plus 5 squared. And then on the right-hand side, we learned that if you have 2 logarithms being added together, you can put those together as one logarithm and multiply the 2 values together. So 12 and 3 can get multiplied. And so this would give us the natural log of x plus 5 squared equals the natural log of 36. Now, what you'll notice is that both sides have the exact same natural log. So similar to number 1, once you get those natural logs by themselves, you can drop them off because we don't need them anymore. And we're going to have x plus 5 squared equals 36. And we're going to solve this equation like we have this semester. So number 1, I'm going to take the square root of both sides to get rid of the squared. So that will give me an x plus 5 on the left. And then remember, the square root property says that when you solve for x and you have to take a square root in the process, you have to include plus or minus on your answer. So it'll become plus or minus 6. And then you're going to subtract 5 from both of those numbers. So you're going to get 2 possible solutions. Beginning with positive 6 minus 5 would give you 1, and then negative 6 minus 5 would give you negative 11. Now remember, I don't know if either one of those answers is good. This is where you have to go back to the original logarithms. So I'm going to circle those, and you have to check by plugging both of these numbers into every blue circle you see. And if any of them give you a negative answer, you can't use it. So let's start with 1. If I were to plug 1 into all of those blue circles, well, 1 plus 5 is 6. That's a positive number. That's okay. 12 and 3, there's nothing you can do with those, so therefore they're okay. So x equals 1 is a good answer. But what you'll notice is if you try to plug in negative 11, especially to that x plus 5 term, negative 11 plus 5 is going to be negative 6. And the rules of logarithms say you cannot have a negative number inside of the original logarithm. So even though we got this answer by doing correct algebra, since it violates the rules of logarithms, we have to cross this one out and not use it. And so for this problem, your only answer would be x equals 1. Now be very careful on your assignments because there will be problems, especially multiple choice questions, that may tell you both answers are correct, but you've got to make sure you don't pick that one if one of the answers doesn't work. All right, and then let me do just one more because a lot of these work exactly the same, but let's do another one where we have to combine. So we've got log base 2 of x plus 3 plus log base 2 of x minus 4 is equal to log base 2 of x plus 12. So looking at this one, if I'm trying to combine these into one logarithm on each side, the first thing I notice is that on the left, you've got two logarithms that are being added together. So as we just talked about, if they're being added, you can put them together with multiplication. So this would become log base 2 of x plus 3 times x minus 4. On the right, you already have just one logarithm, so that one I don't need to mess with. This is log base 2 of x plus 12. Now, as you can see, on both sides, you now have a single logarithm, and so once you get to this point, you can drop the logarithms off and just work with the polynomials. So you'll get x plus 3 times x minus 4 is equal to x plus 12. And we need to simplify this and solve. So on the left, it looks like I can do my FOIL technique that we've been doing throughout this entire term. So let's make sure we FOIL this. That would be x squared for your first, minus 4x for your outer, plus 3x for your inner, minus 12 for your last, equals x plus 12. Also on the left, I can combine those x terms in the middle. So negative 4x plus 3x is minus x, minus 12 equals x plus 12. And all the way back to chapter 1, you might remember that when you're solving a problem that has an x squared in it, you have to make this equal 0 so that you can factor it or try to factor it in some way. So to make this equal 0, I'm going to move the x and the 12 over by subtracting. So I have to do that on both. So that cancels, and you are left with x squared minus 2x minus 24 equals 0. So now we need to factor the left-hand side. So if we haven't done as much factoring recently, but make sure you get your skills out. So you need two numbers that multiply to get negative 24 and add to get negative 2. And so if you think about it, those two numbers would be negative 6 and positive 4. Negative 6 times 4 is negative 24, and negative 6 plus 4 is negative 2. And so now we're going to set both of these equal to 0. So x minus 6 equals 0, x plus 4 equals 0. And if we solve both of these individually, you will end up getting two possible answers of x equals 6 and x equals negative 4. Now, once again, I don't know if either one of those answers is good. So what you're going to now have to do is you're going to go back to the original problem. And I'm going to circle them again. You need to make sure that when you plug these two answers into all of these three circles, they have to give you a positive answer on all of them. If any of them are negative, we will have to cross them out. So let's start with 6. If I plug 6 into all of those, 6 plus 3 is a positive number. 6 minus 4 is a positive number. 6 plus 12 is a positive number. Your answer is x equals 6. That's one of your answers. Does negative 4 work? Well, negative 4 plus 3 is not a positive number. So immediately on the very first one, I know that it does not work, and I can therefore cross it out as one of my solutions. And so one of those things to be aware of is in these logarithmic equations, there is a chance that you could get multiple answers in the algebra, but usually one of them does not work when you double check it with the original problem. So that wraps up the first kind of logarithmic equations I wanted to cover. In the next video, we're going to look at some other logarithmic equations, but in those, we are going to talk about what happens if there's not a logarithm on both sides, and how do you go about solving those?